school doesn't always make you smarter. In fact, school maths can negatively influence your ability to do maths. While you are learning maths in school, you are learning to switch off parts of your brain. And it turns out the parts of your brain that you switched off are the most valuable parts. Adult educators, listen up, because this permeates the adult sector. It's called the suspension of sense making. Now, to give you an example of what the suspension of sense making is, let me give you this assessment task that was used in the US. An army bus holds 36 soldiers and 1,128 soldiers are being bused to their training site. How many buses are needed? Now, there are two possible answers to this. The first one is 31 remain to 12 if you just did the division. And the other answer, number two, is 32 buses. Now, imagine that this was a real life task and you really needed to order the buses to get the soldiers to the training site. If you answered 31 remain to 12, you're going to have 12 soldiers left over waiting for a ride and you're going to look like a complete schmuck. So the people who answered 31 remain to 12 didn't apply it to real life. In fact, they decided that real life context didn't matter. What percentage of people do you think didn't answer 32 but just simply answered 31 remain to 12? Well, of the 70% of people who actually got the division right, only 23% of all respondents who got it right actually said 32 buses. So think about what the other people did. They did the division task, but they decided not to take into account the real life context. They stripped the meaning out of it and just did the arithmetic sum. That's what the suspension of sense making is. It's deciding that in this context, we only need to think about the numbers, but not their meaning in real life. Let's have a look at another example. So here's a maths problem that really drives home the seriousness of the suspension of sense making. There were 26 sheep on a boat and 10 goats. How old is the captain? The crazy thing with this question is that the majority of learners answered it with a number. And that means they stripped out all the context and they just thought to themselves, gee, there are two numbers here. I need to do something with them. I better do that. I'll either add it or subtract it or multiply it or some form of arithmetic. In other words, they took the sense-making part of their brain and they just moved it to the side. We don't need that in this context, which means they're completely disconnecting the maths that they learn in the classroom from the real world. And this is not learners with mathematical difficulties. This is across the board. This behavior is completely anti-mathematical. Mathematics is about using your wits, your cunning, your prior knowledge, your shrewdness, the collective wisdom to solve problems. So what's being taught in school is not really mathematics. Now let's apply this to adult numeracy. We know that roughly half the adult population have numeracy skills below that required to fully participate in society. Numeracy is the bridge between mathematics and the real world. So I think the suspension of sense making is part of this problem. Learners are not able to bring their knowledge of mathematics to real world tasks. Okay, 3 things we can do in an adult environment to improve this. Well, the first thing is to draw adults' attention to it. So for example, you might show them a problem like this and then discuss it. A man wants a rope long enough to stretch between 2 poles 12 meters apart, but he only has pieces of rope 1.5 meters long. How many of these pieces would he need to tie together to make the rope long enough to stretch between the poles? Now, is it solvable? If it's not solvable, why not? And you'd have a discussion about this. But let's just look at it. First of all, we know that it wouldn't work in real life, or we wouldn't be able to work it out accurately in real life. Firstly, because wherever we tied the knots, those knots, we don't know how much rope we're going to be using for each joining knot. And that's unlikely to be the same, perfectly the same for each piece that we need. Second thing is that anybody who's ever stretched a rope between 2 things 12 meters apart in the real world will realize that you need a hang of a lot of tension on those things to make them straight. So unless you're really ranking up the tension on that thing, there's going to be a bit of a sag in that rope. And so again, we're not going to be able to get an exact measure. It turns out, well, when you look at it, the problem just simply doesn't work like that in the real world. So a good idea is to sit back and examine these questions and have a look at them. Now imagine this. Imagine you had a class of adult learners who hated maths, and you put on a PowerPoint and each of these pages had a problem, a bit like this one, and then you were going to discuss why this doesn't reflect the real world. Now, that was all you were going to do. You were going to have 4 or 5 of these, have a big class discussion about the reasons this wouldn't work. That could be the best non-maths lesson in history, and I guarantee that you'll get 100% engagement if you're criticizing maths problems. Could be a great one. So that's number 1, bring their attention to it. Number 2 is to ask learners to identify what they think they're supposed to learn from the word problems. Now, it turns out that a lot of children do work out that word problems are just contrived things to make them practice routines, but a lot of learners, of course, don't, and hence why we have the suspension of sense-making problem. So here's a classic example you might give. John's best time to run 100 meters is 17 seconds. How long will it take him to run 1 kilometer? Well, again, is it solvable? Well, no, not really. In fact, if you could maintain that pace, you're likely to be a world champion. So there's nothing there. But what are we supposed to learn from this problem? So because adults are analytical and critical, we want to get them to cultivate the skill. And I'm assuming, looking at this problem, that it's something to do with division and multiplication. We're meant to work out that there's 10 lots of 100 meters in a kilometer and work it out from there. So there really are skills they're trying to get people to learn, but they've packaged it in this crazy problem. Now, the third tip is to make it real. Now, the problems that you've seen in this particular clip were taken from some research to explore the suspension of sense making. And they gave learners these problems and they asked them questions after they'd done them to see whether they had suspended their own sense-making skills or ability to solve the problems. There was a second part of the research, and the second part got the learners to take the problems out into the field, a new set of problems, out into the field, and really do them. So that is, if they're tying the rope together, they have to actually tie the rope together, they have to saw bits of wood, and so on. Now, when they did the real example, the hands-on stuff, 3 times as many students decided that these didn't make sense and weren't really reflective of the real world. So by getting hands-on and actually doing stuff, they brought their sense-making capabilities back to the task. So that's the key learning point here. In the tertiary sector, in the vocational sector where we are, we have all this equipment, we have real life examples and so on, and yet sometimes we fall back to this worksheet kind of thing, And so embedded literacy and numeracy should be embedded in tasks, not embedded just in resources and so on. And that's a big shift, I think, that's coming over the next few years. So tip number 3, embed these things into tasks, real life tasks, and that will improve your learner's sense-making capability. Hope this was helpful and thought-provoking. Thanks.